3.5 day 2. All right, find all solutions including z complex of 2x cubed plus 3x squared minus 36 equals x squared minus x squared equals x cubed minus x squared plus 9x given x equals 3 is the solution. Now, obviously, unless you've been living under a rock, by now you realize that you need to be setting things equal to 0. So 2x cubed minus x cubed is an x cubed. So I'm just doing shifts. I'm shifting everything left. 3x squared plus x squared is plus 4x squared. Let's see here. The 9x is going to shift over. There's nothing to add it to on the left-hand side. And the 36, she ain't going anywhere. So there's line 1, equal to 0. Now I'm told that 3 is a solution, so it makes sense to do a little of that good old synthetic division. You got your vinculum, your coefficients are 1, 4, -9, and 36. It would also factor by grouping. It would. It does factor by grouping. Takes an x squared, x plus 4, x plus 4, -9. So it does factor too. I just want to do synthetic division with you because, well, it'll make it a little more obvious. Anyways, the acronym was DMA. So we drop, we multiply, we add, we multiply, we add, we multiply. That's a negative. Almost made a sign mistake. Yeah, and we get a 0. Remainder constant xx squared. We're left with x squared plus 7x plus 12, which x and x create x squared. 3 times 4 is 12, and 3 plus 4 is 7. So, if x equals 3 was a solution, this factor is x minus 3. We'll just throw that right there. Easy peasy, kids. Easy peasy. Solve the inequalities by factoring and graphing, and you should try rough graphing by hand. You should graph these by hand, okay? You know things now. So we're going to compare to a 0 is what we're going to do. When we shift left, 4x cubed would be the power function. It's the biggest thing. It's the leading term. The 64x squared didn't get moved, so you're not going to change its sign. Don't be that kid. The x gets shifted left, change its sign. The 16 gets shifted left, changes its sign. Greater than 0. All right, so let's talk about our power function. She is 4x cubed. She will start her day low and she will end her day high. So when I go to my graph, I'm going to be starting low and I'm going to be ending high. Now let's do some factoring and figure out where the zeros are. I can pull an x squared from both pieces. If I pull an x squared, oh, and I can also pull a 4. If I pull a 4x squared from 4x cubed, there's an x over and a 16. And here, it may not be obvious here, but to make x plus 16 be like this, you need the 1 there. Otherwise, you won't have the correct view, I guess you'd say. Both of these things contain x plus 16, and the leftover stuff is 4x squared plus 1, which does not factor. It doesn't. So this is the only 0. And its multiplicity is that it happens one time. So we cross the x-axis. All right, so we have a 0 at x equals -16. So I'm just going to pick a point back here and call it -16. We're going to cross through. We're never going to cross the x-axis again, so we're going to dip down. One thing that would be easy would be to realize that this is the y-intercept because this thing is in standard form. So we'll just pick another point and call it 16. Now it would do something funny in here, and then it would shoot back up because that's just what cubics do. Cubics look like that. Remember x cubed? Remember the graph of x cubed? She's going to do something like that. like that. There's going to be some point where she goes up little drops and then she shoots back up to the moon. Now, the context of the question was about being bigger than 0, and that's anything along that path. And that path starts so long as x is bigger than -16. And yes, you should also learn interval notation, or -16 to infinity. All right, and I think that's the hardest one of the three. 6 is a factor by grouping. 4 is a really blasted easy one. Although on 4, no, none of them have multiplicities of 2. So they're all more or less the same. They ain't hard. Didn't do 7. 8's highlighted. Height of a rectangular storage box is less than both its length and width. The function f of x equals x cubed plus 3x squared minus 4x represents the volume of the rectangular box, where x represents the width of the box in feet. So x is the width. Find the factored form. All right, so factoring 101. I can pull an x from all three pieces. If I pull an x from x cubed, I have x squared. If I pull it from 3x squared, I have plus 3x. And if I pull it from -4x, I have minus 4. That needs to be your second line. If your second line is anything other than this, you're cheating on the Goth app and not even copying everything down. All right, moving forward. To make an x squared, I need an x and an x. To make a 4, I need a 1 and a 4. It's going to be negative, but add to +3, so I would guess -1 plus 3, perhaps. Makes sense. These zeros, which is where the volume of the box has 0 volume, are x equals 0, x equals 1, and most likely x equals -4, which is definitely going to be extraneous. That doesn't make sense, does it? Could a x represents the width of the box in feet? Doesn't make a lick of sense. So let's talk about the real world domain. Both the length, the width, and the height must be greater than 0. So every single factor's got to be bigger than 0. And even this one, which we're going to throw away, this one's a one-stepper, bruh. X is bigger than 1. Her. Oh, well, we have a problem with this one. And this is a Milbrath issue, not a U issue. It's a Milbrath issue. Yeah, yeah. C needs to be omitted because this problem's not set up right. That, which my guess is means 7's not set up right, so this needs to be omitted. If x represents the width, what do the other factors represent? Well, one of them is the length, and one of them is going to be the height. But, yeah, so this must be the length because it's long. It says that the length, well, length is long. X is the width, and it says the height is less. So x minus 1 is the height. I don't like the way I wrote this one out. But anyways, let's do part E. Find the dimensions of the box when the volume is less than 20 cubic feet. So what we're going to do is we're going to put that 20 in place of f of x. And at this point in time, I know that this is not going to work out. Now I want the volume to be less than 20. So the equation itself is less than 20. y1, y2. Asking domain on this one was not a good one because you'll see when we look at the graph that this thing just shoots up to infinity. And I don't think it does it in any nice areas. We'll take a look at the graph and then maybe we'll fix the domain. But looking at it algebraically, it's not going to work. We're going to put a 20 in y1. Going to put the function herself in y2. I just got wore out. This is my third video of the day, in addition to grading papers. And I just kind of zonked out about halfway through this problem. Anywho, Zoom 6. This is where it starts making sense. And the x values don't make sense in the context of this problem. So this is just one of those bad math problems that I made up. Good thing I'm doing this one with you. But anyways, we can definitely answer the last part of the question. I'm going to set my y max to 30 so I can see where I put y equals 20 show up. And hopefully you can see why it doesn't make sense. The box never stops growing, ever. We're going to hit second, trace 5 for intersect. Enter, enter, enter. And I got 2.3445. We'll call that the second x. It's about 2.3445. Now, the first place where this starts making sense is right here where x is 1, because this is where the volume is positive. So the volume, the box has dimensions between certain things. The x value, which is the width, is stuck between 1 and 2.3445. Now, if I plug that in for my length would be add 4. And if I add 4 to 1, I get 5. 5 is less than the length. Give me a minute. I'm working. Don't pester. If I add 5, 2.3445, I'm going to have 7.3445. My width is the small one, which is my height is the small one, which is x minus 1. So 0 less than the height, less than 1.3445. And I think I'm probably going to go back and edit problem 7 so it's not as bad as this one is. This one was pretty bad. It was.